Today, quotient rule. Two things, quotient rule and integer exponents. Quotient rule and integer exponents. So, let's talk about integers for a second. This is like day one material. What is an integer? Usually integers are the ones that we label when we do a number line, right? So I usually start at 0, 1, 2, 3, 4, 5 to the right, but what about the left? Negative 1, negative 2, negative 3. So integer exponents also include those negative whole numbers, okay? So we have a couple of definitions, and let's just go right into it. If I have a to the negative power, a negative exponent, the meaning behind this is 1 over a to the n, okay? This is our rule for negative exponents. So for example, if I have, let's say, x to the negative 2, I want to know what that means, okay? X raised to a negative 2 power, what that means is 1 over x squared, okay? That is the meaning behind x to the negative 2, 1 over x squared. Now, things get tricky sometimes when you have a number in front too. So like let's say you have 3x to the negative 1 versus 3x to the negative 1, okay? A lot of times students get confused on the difference between these two problems. So let's talk about that right now. In this first expression, the only thing that's being raised to this negative 1 power is just the x, not the 3, okay? Leave the 3 alone, the 3 is going to stay where it is. In this bottom expression, because of the use of parentheses, everything in the parentheses is being raised to that negative 1 power, okay? So this one, by this rule here, is just going to be 1 over 3x to the first power, and anything to the first power is just itself. So basically, this will just reduce to 1 over 3x, okay? This one is not. Just the x is being raised to the negative 1, not the 3, okay? So the 3 stays where it is. The x comes down. So that one is 3 over x, okay? And that gets confused all the time. So please, you know, double star that and highlight that, okay? The difference between this guy is 3 over x and this guy, 1 over, the 3 comes down because it's in the parentheses, okay? All right, so where does this integer exponent, negative exponent thing come from? And it basically comes from, these guys work in tandem, the quotient rule, okay? So let's take a look at what the quotient rule says. And then we can do several examples. Quotient rule. Let's say I have x to the 5th power divided by x to the 2nd power, okay? Now, before I put the rule on the board, what I want you guys to do is just see if you can simplify that yourself. All right? X to the 5th power. What does x to the 5th power mean? X times x times x times x times x 5 times, right? So this would be x times x times x times x times x. X squared would be x times x, right? Now, since everything is being multiplied here, and everything's multiplied here, these are factors. And one great thing about factors is I can reduce them. Is everybody with me on that? So I can reduce one of these x's with one of these x's, top to bottom. I can also reduce one of these x's with one of these x's, okay? And that's as far as I can go, because we've run out of x's on the bottom. How many x's are left on the top? 3. And how could I rewrite that as x to some power? X to what power? The third. Does everybody understand what we did there? Okay. X to the fifth means x times x times x 5 times. X to the second means x times x. And then if you reduce, you're just left with x to the third. Okay. And this is a perfect example of what the quotient rule says. When you have the same base powers and you're dividing, that's why it's quotient, because we're dividing these, you subtract the exponents. Okay? So 5 minus 2 is 3. You subtract them. Okay? Yes, sir, a question?
The last example we did right there, so do we, is the answer 1 over 3x or just 3 over x?
So these are two different examples. So if this was your original problem, then this is the answer. Because the 3 wasn't part of the -1 exponent, but this one, the 3 is part of it. So that's why the 3 came down.
Say if the x on there was like -2, what would the answer be?
For which one?
That
The top one?
Yeah.
Yeah, so if it was 3 times x to the -2 power, then again, just this x part is being raised to the -2 power. So the 3 would stay at the top, the x would come down, but it'd be squared. Does that make sense? Okay. Okay, now, let's do this same problem, but let's put more on the bottom than on the top and see what happens. So how about this? I want you guys to do x to the 7th divided by x to the 10th. Okay? Go ahead. Do that problem long by hand, just real fast, and then tell me what you're left with. So hopefully you have 7 x's up here. 1, 2, 3, 4, 5, 6, 7. Down here you're going to have 10 of them, right? Okay, when you reduce, what happens? You're left with 3 in the bottom, right? Now, how do I indicate that these x's are in the bottom and not in the top? There's 2 ways to do it. One way would be what? Sure.
You put 1 on top?
Yes, absolutely. One perfect example is to just write 1 over x cubed. Okay? That indicates that the x's are in the denominator, which is clearly the case here. Okay? But since we learned a new rule today, what's another way to represent 1 over x cubed? X to the -3. Yeah, so either way, these mean the same thing. Okay, and again, if you subtract 7 minus 10, you get -3. Or if you go 10 minus 7, you get 3, but there's 3 in the bottom. Okay? So it's really important that you understand x to the -3 in the numerator means x to the 3rd in the denominator. Okay? That's the meaning behind it based on our first definition today. Okay? All right, so what's going to happen is you guys are going to have variables in the top and the bottom. You're going to reduce, 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 and wherever there's more originally, that's where your answer is. Okay? So in example 1, there were more x's in the top, so my answer is in the top, x to the 3rd. Okay? In example 2, there were more x's in the denominator, so my answer is x's in the denominator. That's the easiest way to keep track of that stuff. Okay? Wherever there were more originally. All right, let's start slowly increasing the difficulty on these problems. All right, let's try this one. Okay, so now I'm putting in stuff that we learned before together with stuff that we're doing today. So first, I want to look at that numerator. We have x squared y, all in parentheses, all raised to the 3rd power. Okay, so that's stuff that we looked at previously in classes. How do I deal with that? What's going to happen there? I have a power raised to a power. That's the only time we ever do what? Multiply the exponents. So you get x to the 6, y to the 3rd, right? There's a 1 here, 1 to the 3rd is y to the 3rd. So now you have this, and you have this. So because of what we learned today with the quotient rule, you can go one more step. Now we can simplify top to bottom with factors, okay? So again, wherever there were more originally, you just subtract and put your answer there. I have 6 x's on top, I have 2 x's on bottom. What is that going to leave? 4 x's on top. I have 3 y's on top, 5 y's on bottom. When I subtract those exponents, I'll be left with 2 on the bottom. Does everybody understand that? Okay? That's how we work these type of problems. All right. Okay, let's do a very similar problem. All the rules are still the same. But I've thrown in some negative exponents to make it a little bit more difficult. Okay, when you apply the power to a power rule, it's still the same rule, but now you have a negative exponent to deal with, okay? So x to the negative 2 raised to the third, that's still going to be multiply the exponents, but you get a negative 6 instead of a positive 6 on this one, okay? Y raised to the third power is still y to the third power. In the bottom you have x squared, and you have y to the negative 5, okay? Now, here is my recommendation as a math teacher to you guys on how to handle negative exponents, all right? This x to the negative 6 means 1 over x to the 6, okay? This y to the negative 5, it's 1 over, but it's just going to come back up. So what I want you to do is anytime you have a factor with a negative exponent, I would just like you guys to circle it. And if it's in the top, you're going to bring it down to the bottom. And if it's in the bottom, you're going to bring it up to the top, okay? When you move it, the exponent is not going to be negative anymore. It's going to be back to positive, okay? So, in finishing up this problem, you have a y to the third that's not moving. You have an x squared that's not moving. You have an x to the negative 6 on top. We're bringing that down to the bottom, and that guy becomes x to the positive 6 in the bottom, okay? The y to the negative 5 in the bottom is going to move up, and that's going to be y to the positive 5. Once you move the negative exponents, top to bottom or bottom to top, it's now a positive. And these are much more user-friendly once you have all positives. Okay? All right, how would I finish this problem? I have y to the 5th times y to the 3rd. Based on our product rule, what do I do with those exponents? Add them. Y to the 8 divided by x to the 8. So there's a lot going on in that problem. All right, so step by step, we did power rule, multiply the exponents. Negative exponents, I had 2 of them, I moved them. Then you have all positive exponents, then you just simplify, okay? All right, how about this example? A squared times a to the negative 3rd times a to the 8th. A to the negative 2 times a to the negative 3 times a to the 8th. What do I do when I have all the same base and I'm multiplying? What do I do with the exponents? You add them up, right? So what is negative 2 plus negative 3? Negative 5 plus positive 8. Your answer would just be a to the 3rd. Okay? Let's do a very similar problem. Three x to the negative 2 times 5x to the negative 8. Okay. This one's a little bit trickier because I have coefficients now in front of the variables. My rule for this is I multiply the coefficients together, right? Just like before. It's the same rules that we had several days ago. 3 times 5 is 15. Do that part first. Now I add the exponents. I have x to the negative 2, x to the negative 8. That adds up to x to the negative 10. Okay? Now, in your homework, in your book, on a quiz or test, they're going to say to simplify and not have negative exponents. Okay? So when you have a negative exponent, like I just showed you a minute ago, if it's in the top, you move it to the bottom. If it's in the bottom, you move it to the top. So I have one more step to go here. The 15 stays where it is, but this guy here moves down to the denominator. And that would be your final answer. 15 over x to the 10th power. Okay? All right, let's try this one. 7 x to the negative 10, y to the third, z to the negative 8, over 21 x to the negative 5, y to the negative 2, z to the 11. Okay? All right. The very first thing I would do in this problem is I would circle any of those variable factors that have a negative exponent, and I would move them. That would be the very first thing I would do. Okay? So I'm going to help you out. This x to the negative 10 I'm going to move. X to the negative 5, z to the negative 8, y to the negative 2. Those four things that I've circled, your first step should be rewrite this fraction and move those four pieces. Okay? So move the 2 down that are in the top and move the 2 up that are in the bottom. So do that first. That's all I want you to do first. Move those four negative exponents. And realize everything is being multiplied here. Okay? These are all factors. So see if you get the same thing that I have. You have a 7, you have a y to the third that's already there. You got these two guys coming up, x to the 5th, y squared. You have a 21 that's already in the bottom. You have a z to the 11th that's already there. And you have an x to the 10th coming down and a z to the 8th coming down. Okay, that should be your first step. Those four negative exponent pieces I moved. Okay, so you should have something roughly like this. It doesn't really matter the order because multiplication is commutative. Okay, so as long as you have the same things up in the top and the same things in the bottom, you have it right so far. Okay, now what can I put together? Well, in the top here, I have a y to the third times a y to the second. I can add those exponents. That's just a product rule, right? So I have a 7, y to the 5th, x to the 5th. 7, y to the 5th, x to the 5th. In the bottom, I have a 21. I have an x to the 10th. I can't really do anything with that, but I have a z to the 8th and a z to the 11th. Again, I can combine those. If I add the exponents, z to the 19. Okay? I'm still not done, however. Now, I reduce top to bottom. Well, we have coefficients of 7 and 21. 7 goes into 21, right? 3 times. So, I'm going to have a 3 from that. Now, look, I have a y to the 5th, an x to the 5th, an x to the 10th, and a z to the 19th. Well, the y to the 5th, there's no other y's, there's no other z's, but I do have an x to the 5th in the top and an x to the 10th in the bottom. When I subtract those exponents, where do I have the answer? In the bottom, right? X to the 5th. And that's it. So a million things happened in that problem, okay? First thing is I moved all the negative exponents. Second thing is I combined what I could, okay? Last thing, I reduced top to bottom. 7 goes into 21 3 times. We have x to the 5th and x to the 10th. That leaves x to the 5 in the bottom, because there were more in the bottom to start. Okay? Question on this one? All right. So let's take a look at as bad as it can get then. So we'll do 2 or 3 that are ridiculously difficult. So if you can do these, you can do any of them. All right, we ready? Let's try this. 2, x to the negative 1, y, z to the negative 3, over 14, x to the negative 2, y to the third, all of this to the negative 2. Okay? This is an awful problem. Okay. The first thing that I have to deal with, there's a lot that I have to deal with, but I have all of this is raised to this power, okay? So everything inside of the parentheses is going to get raised to that power. I have to deal with that first. So that's the first thing I'm going to do, okay? Now, when you just have a coefficient raised to this power, you just write it down. But when you have a power raised to a power, you do what? You multiply, okay? Power raised to a power, you multiply. All right, so I'm just going to do this step by step, okay? The first thing that I want to do is, there's a 2 to the negative 2. The coefficient, you just write it. X to the negative 1 raised to the negative 2 power, I multiply those exponents. And that gives me what? Which is actually kind of nice, right? X squared is a positive number, so that's going to work out great. Y to the, multiply those exponents, you get negative 4. Multiply these exponents, you get positive 6. Okay? So just double check that you understand what happened in that top row. The 2 got raised to the negative 2, and each of those variables got raised to the negative 2, but those were power to a power, so I multiplied the exponents. Okay? Now down to the bottom, all of these get raised to this power too, so I have a 14 to the negative 2. I have power raised to a power, so that leaves x to the 4th. And I have power raised to a power, so that leaves y to the negative 6. So I've done one step so far. In that one step, I just made sure every single thing in here got raised to this power. Okay? That's all I've done so far. All right. Now, as before, I recommend you guys circle all of the things that have a negative exponent. And it's not so bad. We only have 4 of them. Move those. Okay? So the ones on the top, bring them down. The ones on the bottom, bring them up. And let's see what we get here. So I'm going to bring this guy up. You have a 14 squared. You already have an x squared up there. You're going to bring a y to the 6 up and a z to the 6. Okay? I have a 2 squared that's going to come down. I already have an x to the 4th down there. I'm bringing a y to the 4th down. And I guess that's it. Did everybody get that for their next step? Okay? Now we're almost finished here. In the top, I have x squared y6 z6. That's great. In the bottom, I have x4 y4. Okay, so there's some subtracting of exponents I can do here. What about the 14 squared and the 2 squared? Well, I'm not sure what 14 squared is, so can somebody tell me what 14 squared is?
196.
196? So let's simplify that. We know 2 squared is 4, so let's double check that 14 squared is 196, is it? Oh, that's awesome. So let's double check your head math. Is it 196? Great, awesome. All right, now I have an x squared and an x to the 4. What's that going to leave? X squared where? In the bottom, great. I have a y to the 6 and a y to the 4. That leaves a y to the, subtract the exponents, y squared in the numerator. And I have a z to the 6 that's just staying there the whole time. Okay? Does 4 go into 196 would be the next question. How many times? Is it 49? Yeah. Okay, great. So if it goes in perfectly, then obviously reduce it. That's my answer, okay? Again, this is as bad as it gets, guys. If you can do this one step by step by step, get this answer, then you should be fine with these, okay? I'm going to do a couple more of these really hard ones, just so you can get used to the pattern of what we do. Okay. You guys try this one on your own for a second. Let's do 3a, b, c to the negative second. 9, a to the negative 2, b, c to the 8th, all to the negative 1 power. Go ahead, try that one out. See if you can work it all the way through. While you're doing it, I'll try myself. Let's see if we match up answers. Anybody get 3c to the 10th over a to the 3rd? If so, you guys are masters. So the first thing I did is I applied the negative 1 exponent to every single factor. That unfortunately left a lot of negative exponents. I moved every one of those negative exponents, which produced this. And then I simplified where I could. If they were on the same line, I add the exponent. C10, C2 is C10. A1, A2 is A3. B on the top and a B on the bottom, those just reduce out, right? B divided by B is just 1. Okay. So you get 3c to the 10th, a to the 3rd. This puts together everything. You have a product, you have a quotient, you have to multiply exponents sometimes, you have to add them sometimes, you have to move all your negatives. So a problem like this incorporates all the stuff that we've been doing. Okay, any questions? All right, I'll get, yes?
In that last part, do you subtract the exponent?
Where?
The last step.
So, if they're on the same line, you add them. If you have a top to bottom, you subtract them.